Hello everyone and welcome back to the SwiftUI Academy. In today's video, we are going to talk about how you are going to use the camera inside your SwiftUI application. We have two ways to actually previewing our camera inside our application by using the SwiftUI technique and the combined framework, and also with the AVKit framework that already Apple provided for us as the AV player preview layer that we can add it on the top of our UI views. So which one is better? Let me describe a little bit about how things going on in the camera and how we are going to preview things inside our application. Each frame that coming from the camera as a device is just like as in an image. For example, when we are setting our camera to using the 30 frames per second, it means that the camera device sending us 30 images on each second. So guess that when the image coming, we can actually use that with the combined framework and show it inside our application. To refresh your mind, SwiftUI actually using the data to render the views. It means that when you have a new data, SwiftUI going to be destroy the struct of that view and render the view again. So what if we have the combine here to listen to each frame that coming from the camera and pass it to the view with the publisher and subscriber, and then we show that image inside our view in the SwiftUI. But this is one way with using the combine and camera. How about the AV player or AV preview layer that coming from the AVKit? Let's discuss more about it in the code. But first of all, please subscribe to this channel and like this video if you like that, and hit that bell icon. I'm going to later on to show you how you are going to create a well camera application and adding so many filters based on the ML or iOS vision, or even create a barcode reader to read the driver license or QR codes. Let's jump to the code. I will show you more in details. Alright guys, now let's see in action how the combined framework with the SwiftUI gonna help us to preview the camera, and how we can actually use the AVKit from the UI kit to preview a camera layer inside our application. I created an application for you and put the link inside the description below, so make sure to check it out and download the source code to going through the app and navigating through each classes. Maybe it will be useful for you to use it inside your application as well. I'm just going to walk you through each class to show you how things working together. As you can see, we have a content view here. This is just a normal SwiftUI stuff with the navigation stack here, and also I'm going to have two buttons here that one of them going to present us the combined camera view, and another one is going to show us the AV preview from the AVKit. This is just a normal Swift stuff, so I don't want to waste your time on that. The most important part and the critical class that we are using here is the camera manager. As you can see, when we want to use the camera inside the Swift application or iOS, we need to define a session, an AV capture session. But I want to show you when we are going to use a session, it will be so good if we are using the threads and specify another thread when we are going to handling the camera, because if you have something like the processing for each image or camera is going to do something behind the scene, it's better to have those processes inside its own queue or thread. As you can see, we define the session queue here, and when we are going to starting the session and configure it, we are always actually using that thread for that. As you can see, we first need the permission from the user to give us the permission to accessing the camera, and when we are going to do that, we suspend that queue because we are waiting for the user response to give us the authorization. As soon as the user authorize the request for the camera access, then we are going to resume our query to start the session for the camera. And if you actually scroll down inside the config capture session, we are going to defining the device that we are going to use. As you know, iPhone devices has multiple cameras, so we can actually specify which camera you are going to use. We can have the built-in dual camera, we can have the tele camera or wide camera, whatever you want, and even you can specify you are going to use the selfie camera or you are going to use the rear camera from the back of the device. Then we are going to specify it as an input to that session. Then we are going to add an output. Okay, we have the input as a device of the camera. We can also have another input like audio, and then from that output we are going to define our delegate that's sending us each sample buffer as a kind of image. So where we are going to handle that delegate inside our frame manager. Inside our frame manager, we receive that image buffer that coming from the camera delegate as an CV image buffer. It is not kind of the UI image to show it inside the UI, so we have to somehow process it. As you can see, because we are going to pass it to the main thread for the view, to present it to the user, we have to pass it inside the main thread. And as you can see, because the frame manager is an observable object, we are using at published as a property wrapper for the CV pixel buffer, that type of the image buffer camera actually sending to us. And then we can use this frame manager inside our views or our view models for each view that we want to present it. So we now have image for each frame of the camera. So for example, if we open the views folder and going for the combined camera view mode here, we have the view model of the combined camera view mode, and we already have the frame manager because it is a singleton. We can actually have access to that, and we have another publish here as a frame. But when we are going to set the subscriptions to our current from the frame manager, we can actually define whatever we want on that. So first of all, we are going to use the receive modifier to specify it on the main thread, although we specified that in the previous class, but it's always good to identify, hey, we want it to access inside the main thread. And then we are using the compact map because somehow the image that coming from the camera, maybe it is nil, and with the compact map we are going to reduce those nil images or ignore those, and then inside this closure of the compact map we already have the image that we can actually process them. And we have an extension for the CGI image inside our extensions here that converting the CV pixel buffer to a CG image. It will be usable for us inside each view. So inside our compact map closure, we are actually having some kind of the filters. I'm going to describe it a little bit later. Because we have access to each image of the frame, we can actually put whatever we want on that image or process it. Then we are going to assign it to our view model frame here, and it is a publisher. And because of that, we can have it inside our views. But when we are going to present it, I created another actually view as a camera frame view that it will be take the frame, that image that coming from, and process it, just to make it so clear, because later on we can actually put so many frames and ratio on that, and we can actually not only put it as an ignore safe area to cover all the view, all the iPhone frame. When the frame change inside our view model, we are listening to that, this strike going to be displayed again. If I run the application, Okay, our application is now running. So if I click on the camera combined view, as you can see, it will bring up the app for us, and it will rendering all the image that the camera is sending to the frame manager. If I moving my fingers through the camera, you can see that how smooth it is, and we are actually presenting it. On each frame, this view is going to be rendered again. Remember when I told you about the filters that we have inside our view model? If I click on those filters at the bottom, because we are accessing to each frame and each image, we can put whatever or what kind of the filter or how process it with the, for example, with the iOS Vision or AVKit or Google ML for the barcodes or whatever we want, we can have access to that. So now let's click on the back. I want to show you how we are going now to use it as the AVKit with the AVCaptureVideoPreviewLayer. If we open the AV preview mode here, you can see that we have just two class here, two struct, one class. One is from the UI view, because we are going to use the AVCaptureVideoPreviewLayer. It is a layer from the AVKit, and then we are going to use the UI view representable that allow us to use a UIKit view inside our SwiftUI. It is so simple. As you can see, the only thing that we need here, our session. We can pass the capture session that the camera manager actually provided to us, and then we can use our camera preview holder inside each view that we want. So if I bring up the device again to see how it is working, and I'm clicking on the AV preview camera, as you can see, it is just working like that. And because we are accessing to that session, we can rendering so many layers to the AV preview as well. So these are two ways to showing the camera, but which one is really better? Let's find it out by investigating in memory and resources. So now I'm going to bring up application again, and also going to remove these inspector for the resources. So let me put the device preview here so you guys can see it, and as you can see, we are using almost 14 megabytes of the memory, and the CPU is almost 0. When I click on the AV preview camera from the AVKit, the CPU is around 2-3% and the memory is 20 megabytes. And when I come back and using the combined camera view, the CPU usage is going up for 45%, 50%, and the memory is a little bit higher than the previous one, 27 megabytes. But these are just based on the preset of the session that we are using. In the session, we can actually define what kind of the resolution or quality we are expecting the camera to provide it to us. Now, as you can see, I set it to the HD with the 720p. But what if we are trying to record the 4K? As I can specify it here, you can see that we have a lot of options here. I'm clicking on the HD 4K mode, and let's rebuild the app. Okay, bringing up the real device here. Now we have the device. Let me click on the inspector memory here. As always, it is just 14 megabytes because nothing happening behind the scene. I'm clicking now on the AV preview camera as the UIKit provided for us. Now the memory is almost 2 times than the before. We are using 48 megabytes now based on the HD recording, and it is just a preview for that. Let's see what will be happening if we are going to use the combine now. If I click on the combine preview, wow, we are now using much more memory and also CPU usage. That's because when we are trying to pass each frame as an image to the preview it inside our view, we are passing the 4K image with the high resolution aspect ratio, and the size of the image is high. because the resolution of that, we define it as the 4K, and it is going to render those images inside the view. And things going to be worse if we are trying to applying so many filters like that. If you can see, I just apply one filter and the memory goes up. And if I apply another filter on that, see what will be happen. I apply and wow, the memory goes up again. So this is what will be happening when you are going to use the combine based inside your application for the previewing actually the camera. I'm not going to say that it is not a good way to use the combine for previewing the camera inside the SwiftUI, but it is depending on your use cases. If you are trying just to scan something and you don't need high resolution and you are trying to accessing to each frame and in each image easily, you can actually using the combine and the SwiftUI. But if you are dealing with the 4K or the high resolution or ProRes, definitely this is another option that AVKit provided to us. So I hope you learned something in that video, and based on your use cases, you are going to use the camera very smarter. If you like this video, please subscribe and hit that bell icon. I will create another video to show you about how you can actually record from the camera with the AV Asset Writer, even in the 4K with the low memory usage and the CPU. Until the next time, see you.